what I'd like to do, maybe Naresh, Guy, you guys could lead this off and talk about the importance of doing 5G analytics at cloud scale and what that means, versus what's been done in the past, which is typically sort of an on-premise based approach. Why don't we talk through the virtues of that approach here? I don't know who wants to take it first, Naresh or Guy.
Yeah, sure. Yeah. So if you see today, right, I think from an NWDAF perspective, I think the two fundamental piece of it is one is the data collection, another one is the analyzer. So irrespective of the use case that what 3GPP has defined, I think our thought process here is like NWDAF will actually finally evolve into one unified analytics portfolio for most of the operators. Like, because today they all have a siloed kind of analytic solutions that it is either looking into RAN separately or core separately, like we mentioned earlier. But I think NWDAF will become a the centerpiece of the equation when it comes to driving the 5G connectivity calls, or even enterprise managing intelligent service assurance slices and things like that. So when it comes to the cloud operation, first of all, the first thing is the dynamic challenges of ingestion of data, right? I think whether you do it at the edge or you want to do transport it back to the region. So AWS actually helps in scaling and collecting those data sets, different type of data sets that is getting originated from different network functions. That's one of the most important aspect of it. So we have seen operators trying to deploy 5G, and some of the core data functions, like whether it could be UPF, can be sitting at the edge, and also some of the control functions can be sitting at the core region. So today NWDAF talks about a distributed network, and AWS is perfectly poised to provide that kind of a distributed architecture, because primarily that we do have an expertise in driving these kind of distributed architecture at scale. And most importantly, I think the data prep problem, right? I think you're ingesting so much of a variety of data sets, and you wanted to correlate the data, wrangle the data, and make it usable for you to drive a use case is something that where cloud helps you to solve it. And then explicitly, like we have seen data scientists build a miniature AI ML model with their miniature data sets, but once they throw it out in production, the results goes haywire. So basically with the help of AWS, you can dynamically scale the compute power, and also bring a lot of AWS native machine learning services that where you can readily make sure that some of the models that you're building as part of analytics will be really scalable and readily deployable in production. Guy, if you have anything to say?
Yeah, thanks, Naresh. Just my comment here will be that basically, as you can see from the diagram, we want to see how we can help our customers in terms of bringing the NWDAF edge capability to the edge. And this is where we were working closely with the Guavas folks on deploying the NWDAF edge on AWS Outpost. And AWS Outpost is essentially, if you think about it, just a physical rack, a hardware appliance, very similar to any other AWS rack in an AWS data center. So from the customer perspective, it's a seamless experience, right? They deploy an AWS rack completely that AWS are completely responsible for. They deploy it on their on-prem data center, close, for example, to the UPF. And then we can start, hosting those NWDAF capabilities like the collector and other elements as well to collect the data close to the network elements, right? So then we can do the pre-processing and discarding irrelevant packets and send only the relevant data to the central component in the region.
Exactly. Andrew, anything you want to elaborate on here in terms of flexibility, scale, extensibility?
Yeah, I think it's actually a really exciting time. I've had fortunately, I've been in this kind of telecom OSS operations space for hard to admit, but 30 years, and it's really amazing to see the kind of changes. Being at Guavas now, and really being focused on how AI ML is created and can be deployed to telecom operators, being able to leverage these hyperscale connectivities that are available in these cloud environments and available from Amazon Web Services has really been phenomenal, because we know, for example, how to effectively define and build machine learning algorithms, but they need to be trained, and they need to be trained and periodically need to be retrained and adjusted when they're actually in deployment. That's a huge resource burden from a CPU, memory, and sometimes even storage I/O perspective. So being able to leverage these kinds of cloud capabilities where you can burst up and do things like model training, which we know how to do very effectively with ML model operations in centralized core data centers, and then push that knowledge out, that information out for the ML models to edge deployments where they can actually be scored, because that edge scoring is actually relatively inexpensive from a CPU memory perspective. We know how to do that very, very efficiently, and that's really effective. So this separation of edge and core functionalities, it's what Glavis has been doing for years. I can see this coming in the 3GPP specs, which is really exciting to me when the specs kind of line up with what we know is kind of the way things work in the real world. Sometimes they do, sometimes they don't. Really, it's really a superior time to be in this environment, to leverage these capabilities, and to be able to make that a reality and bring these technologies together across the kind of hyperscale world to the telecom world, and enable it in 5G services and operations.